Imagine yourself 20 years from now. Barring any new traumatic brain injuries or neurological disorders, which cognitive tasks do you expect to continue to excel at, and which do you think you'll struggle with? For example, do you think you could easily remember an old coworker's name or handle interruptions like a phone call while you're deep in concentration? Or how about calculating the tip on your restaurant bill in your head? Well, scientists have studied which cognitive abilities will stay strong as we grow older, and unfortunately, they have some bad news. Each line on this graph represents a cognitive ability like memory or attention. And what this graph shows is that mental abilities like memory, reasoning, and your mental processing speed decline as we get older. This other line, the red line that seems to buck the trend, represents vocabulary knowledge. So if you studied your SAT words properly, you won't be forgetting those anytime soon. Now, you might be concerned about this downward trend and wondering whether there's a way to reverse it. Some people believe that doing some cognitive training, like playing brain training games, can help. Now, it's still very unclear how much they do help, and scientists are still hard at work studying them. However, these games are popular enough that we can still learn some interesting things about aging by studying how well people do on these games. For example, younger adults usually outperform older adults on these games. However, if the older adults play these games for a long enough time, then they can catch up in performance to the younger adults. Isn't that pretty cool? Let me share with you an example. Here's a game testing short-term memory. Specifically, you were first shown a shape, then the card is flipped over and you were shown a different shape, and you have to determine whether or not the two shapes you just saw were the same. So this is what the game looks like in practice. Again, you just have to make the decision whether or not the shape you are seeing is the same exact shape as the shape you saw before, and try to do it as quickly as possible. That's just one memory game of many that I studied. Next, I want to show you a graph showing this catch-up effect on the memory games. In this example, we will be comparing people in their 70s to people in their 50s. The x-axis represents the number of times a 70-year-old has played a memory game, while the y-axis represents the probability of them being able to catch up in performance to a 50-year-old. What you want to pay attention to here is that dashed black line. That represents the threshold of catch-up. Next, you will see some colored lines appearing, which represent the practice level of the younger person, the 50-year-old. If any of the colored lines cross over the dashed black line, then that means a 70-year-old can catch up to a 50-year-old on these memory games. If the line doesn't cross, then it doesn't seem likely that the 70-year-old can win. Well, in this case, the younger adult has practiced 100 times, so catch-up would be hard to achieve. So how about let's look at some lower practice levels for the younger adult. Okay, so in this case, the lines have moved slightly up towards the black line, but it's still too difficult for the 70-year-old to overcome a younger adult who has practiced 60 times, as in this case, or even 40 times, though catch-up looks much closer now. So how about we lower that practice level just a bit more? And indeed, catch-up is achieved. Specifically, if a 70-year-old practices this game 60 times, they could beat a 50-year-old who has only practiced the game about 20 times. That may seem like a lot more practice, but I think that beating someone 20 years younger than you in a memory game is pretty impressive. So the takeaway here is that practice makes perfect, regardless of age. If there are certain cognitive skills you want to make sure you keep as you get older, make sure you keep practicing them.